Hello, welcome to this lesson. In this lesson, we also solve another example, a nice example. So let's choose a function y of n given by n times a to the power n, where a is an arbitrary constant. Now, the forward difference of y of n is given by this, that's n plus 1 times a of n. You just have to replace n by n plus 1, then minus the function itself, okay? And this is the same as when you expand bracket, we get n times a to the power n plus 1 plus n a to the power n plus 1 minus this term, okay? Now let's group the first term and the last term, okay, since each of them is multiplying by n. So we obtain na to the power n plus 1 minus na to the power n plus the last term, okay? But n times a to the power n plus 1 can be written as this, since a exponent n plus 1 is the same as a times a to the power n, okay? So when you multiply by n, you obtain this minus the second term and the last term. Now when you consider these two terms, we realize that there are some common factors, okay? That is n times a to the power n. So we factorize it out. When we factorize it out, on the first term we are left with a, then the second term will be minus 1 plus the last term. Now we try to make this term n times a to the power n the subject. Don't forget that is given by what? The function y of n. So we make it the subject, okay? So when you make it the subject, you obtain forward difference of y of n, okay? Forward difference of y of n, forward difference of y of n divided by a minus 1 minus a exponent n plus 1 divided by a minus 1, okay? But you see, there's a forward difference. We want to find the sum of both sides, okay? And before we can do that, we need to express this term, okay, in terms of forward difference. So first of all, we can rewrite this a as what? This a exponent n plus 1 as a times a to the power n, okay? But in our previous lessons, we realized that this a to the power n is given by this, because when you have a forward difference of a to the power n, that is a to the power n plus 1 minus a to the power n. Now let's try to make a to the power n the subject, okay? So you see, this can also be written as a to the power a times a to the power n minus a to the power n, okay? Then when we factorize a to the power n out, you obtain a to the power n minus times a to the power n multiplied by a minus 1, okay? Then we divide through by a to the power n. So when we divide through by a to the power n, we obtain this, okay? So now we can substitute this one here, and when we do that, we obtain, so this is our first term, okay? We have it here, okay? Then let's pay attention to this term. Already we have this term already, that is a divided by a minus 1, okay? And this a to the power n, which is delta a to the power n divided by a minus 1. So this will be like a over a minus 1 times delta a to the power n, and a to the power n is just delta a n over a minus 1, okay? And this will be a over a minus 1, that is a minus 1 all squared delta a to the power n, okay? And that's what we have here. Now we have delta on both sides, that's the forward difference. So we can factorize it out, then we find the sum on both sides. Okay, so let's find the sum on both sides. Okay, so when you find the sum, we choose a dummy variable. Okay, that's find the sum as r starting from m up to n of y of r. R is our dummy variable. Is the same as the sum of this, but this constant. Okay, this constant, so, or scalar, so you can bring it out of the sigma sign. Then the same thing applies to the last term. Okay, now when you consider this part from theorem, okay, the theorem that we learned in one of our previous videos, you realize that when you have this, we can rewrite this as that. Okay, you can go back to the videos and you can revisit that videos again. Okay, you can visit that video again. Now, so we have this one. Okay, so the summation of delta y of n is given by y of n plus 1 minus y of m minus a divided by a minus 1 all squared, and delta a exponent n is given by a to the power n plus 1 minus a to the power m. Okay, so when we simplify this, this can be written as that. Okay, we can rewrite this as this, it's just the same thing. Okay, but don't forget our y of n was given as n a exponent n. Okay, so therefore our y to y of n plus 1, you just replace n by n plus 1. So our y of n plus 1 will be n plus 1 a exponent n plus 1. That's what we have here. Then our y of m, you just replace this n by m. That will be what? M a exponent m. And that's what we have here, divided by the denominator. Then we maintain the last side. Thank you.